All stressed parts, such as forgings and castings, are X-rayed for any possible flaws in the metal. Lockheed X-rays more parts than all other aircraft manufacturers combined. They may look new and shiny on the surface, but that doesn't matter. What are they like underneath? This batch is fine, perfect. A different story here. Those slight, almost imperceptible flaws which doom it to the scrap heap would be invisible to any eye other than the X-ray. Therefore, although it is important to know what is on the outside of a plane, every stressed part is X-rayed because Lockheed thinks it is even more important to be absolutely positive of what is on the inside. Yes, every part of this plane is built for the strength, ruggedness, and durability to achieve the highest speeds. And there goes the Lodestar. Carrying a full load of 17,500 pounds, it speeds down the runway for the takeoff. In 15 seconds, after a run of only 860 feet, it leaves the ground and soars into the air. Climbing rate 1,200 feet per minute. And while the plane is in flight, the dials and indicators on the panel are the guides by which a pilot flies. Over a half a mile of wire connects them with the controlling instruments, which must be infinitely accurate before they are installed. In the instrument testing laboratory, each instrument and accessory is, to all intents and purposes, actually flown before being installed on the plane itself. For instance, on this stand, a motor duplicates the swing of a plane to test the turn and bank indicators. Here, tachometers are also tested, and propeller governors, vacuum pumps, fuel pumps, starters, generators, and hydromatic motors for feathering propellers. The automatic pilot is checked by a vacuum system against mercury manometers. This small box can guide a plane in flight, keep it as true to its course as the most experienced pilot. An airplane is a chain of which the thousands of separate parts are the links. They must be forged together in order to shape the wing, the tail, and the fuselage. The duty of the wing is to provide the lift that sustains the flight of an airplane. Here in the plant, it must be assembled as flawlessly as it was designed. Although a wing is generally considered as a unit, it is really composed of 3 parts, 2 outer sections and the center section. We are all familiar with the general shape of a wing, but while an outer section is in the first stages of assembly, we can get a good idea of the complex structure on the inside. Every rib and crosspiece has its purpose. Remember, it was just a small part of the wing that we saw withstand a compression of 80,000 pounds. Each operation is executed with precision and care as the outer section moves down the production line and takes shape. High-speed electric drills punch holes for the rivets. There are more than 700 drillers or riveters who have all had previous training. Even so, before they're assigned to actual production, they must attend Lockheed's own school until they can uphold the plant's standard of efficiency and skill. There are more than 50,000 rivets on a completed wing, and every one of them is checked, examined, and checked again. This requires an army of over 200 inspectors, such as this one. But by the time a Lockheed plane is assembled, every square inch of it has been inspected at least 5 times. Inspector number 158 finds this row perfect and okays it. And the story of one outer wing section is the story of 10, of 20, of 1,000 sections as they move down the line in an endless parade. Mass production with the emphasis on precision and quality. The assembly line for the center section of the wing is one of the largest and most vital units in the plant. It has to be because the center section is the strong man of the plane. It must be constructed and assembled so as to be able to support heavy loads and to withstand great strain, for it unites the 2 outer wings with the fuselage. The fuselage will eventually rest in the gap between the 2 shoulders, and the wings will be joined like arms on either side. The main beam of the center section is the strongest part, the backbone of the entire plane. Like a bridge, it must carry any burden with steadfast dependability. And the main beam is built just like a bridge. At all times, it carries all of the flying load, the engine load, and the landing load. And it is stressed to support more than 5 times the total weight of a fully loaded plane. Completed and assembled, capable of supporting a static load of 70,000 pounds, the wing will do its job as the men who built it have done theirs. The tail surfaces control the maneuverability of a plane. The use of twin rudders was developed by Lockheed and are one of the distinguishing features which point out every Lockheed. The fuselage is the body of the plane. It represents the final word in aerodynamic design and streamlining. And during construction, these basic principles are built into the fuselage and applied to every operation from the beginning to the completed shell. As the first step in its assembly, the bulkheads are joined together by stringers which form the basic shape and strength of the fuselage. Skin fitters then fit and shape the metal sheets, attaching them with removable fasteners. On their heels come the riveters, while every stage of the assembly is constantly under the close check of inspectors. Assembling with electric continuous spot welders facilitates production and gives many fuselage parts an extra smoothness for better streamlining. With an eye to the future, Lockheed is constantly enlarging on this process because better streamlining means greater speed. And so another fuselage is finished and ready for mating with the wing. Like a ship being launched, it moves slowly down the ways. Slowly now, yes, but for just a little while longer. Soon sunlight will be glinting from its metal sides. Its nose will point upwind. In the comfort of its cabin, passengers will read or write or sleep or think after their own fashion, and beneath it, the lakes, rivers, and valleys of the countryside will unfold. Slowly still, the fuselage is lowered into place, united with the wing, and now, slow no longer. Speed on the water. Speed on the snow. Speed on wheels. On rails. Speed on wings. There is truth in the slogan that it takes a Lockheed to beat a Lockheed. And as the plane approaches the field, it slows down for the landing. The Fowler flap has been adopted and developed by Lockheed. The flap gives a greater lift to the wing and provides a brake action to reduce the speed. The plane lands at 65 miles an hour, and from a height of 50 feet, it can come to a complete stop in less than 600 yards. This Lockheed Lodestar, with its safety, its comfort, and its great speed, typifies the ideals of aviation in America. To protect these ideals, Lockheed is contributing its share toward national defense and the defense of democracy in other parts of the world. These B-14 bombers, better known as the Lockheed Hudson bombers, are rolling off the production line at an ever-increasing rate. They have been ordered in great quantities by Great Britain and Australia. When ready for delivery by boat, the Hudson bombers are dismantled. The sleek fuselages are carefully encased in canvas, and the wings, already stowed away below deck, are crated in wooden frames for safe shipment. When the planes reach their destination, they are easily reassembled and soon ready to take their places in the staunch defense of the British Empire. And while these planes start on their long journey by water, others are being given their final test flights for the tough job ahead. And still more are winging their way directly toward Canada. In combat, in actual line of duty, the Hudson bombers have won a name for their efficiency and dependability. And as America builds its planes for commerce and for defense, it is well to remember that Americans invented the airplane and developed the modern conception of mass production used by Lockheed. And out of the vast production line come Lockheed's, the 212, the Electra, the 12, the Hudson bomber, the Lodestar, and now Lockheed's answer to the challenge of our times, the Interceptor Pursuit P-38. It has been developed solely for national defense, and Army officials consider it the fastest military plane in the world today. The P-38, a man-made comet. The P-38 is a completely new development in conception and design. The purpose of this deadly single-seater fighter is to prevent any would-be attacker from reaching his objective. Lockheed is building vast quantities for the United States Army, and many of its features are closely guarded military secrets. But it can be revealed that the P-38 will climb a mile in a minute, and its motors are so quiet that it can approach any target almost without warning.